Hello my dear friends. Welcome to a new video. Today we're going to solve the merge two binary trees on LeetCode. As an input, we will have two binary trees. And to be more precise, we will have the root of the two binary trees. Okay? And then as an output, we need to return the merged version of the two binary trees. In order to merge these two binary trees, we need to add up the values of the nodes if they are at the same position. For example, here we have 1 and 2 are both the roots. So in the resultant merged binary tree, we will have a tree here because 2 plus 1 is 3. Then we're going to traverse the other nodes, the children nodes, and do the same. Here we have 3 and here we have 1. 3 plus 1 is 4. Same thing for 2 and 3. 2 plus 3 is 5. Then 5 plus nothing, so 0 is 5, okay? And because here we have nothing, we just can put the rest of our nodes. So we put 4 and we put 7. Now the question is, how are we going to solve this problem? Well, it's pretty simple. We're going to use the recursive approach. So at the beginning, we're going to check if the roots are null. In our case, the roots are not null. That means that we can add them up. That's what I'm going to do. So I'm going to add 1 plus 2, that is 3. Oops, wrong tool, so 3. And then what I need to do is, I need now to merge the left subtree with the left subtree. And I need now to merge the right subtree with the right subtree. Okay, so I'm going to call this like 1 and this 2, 2. So we have two recursive calls. Okay, so now I want to merge these two subtrees. Okay, we have their roots 3 and 1. So 3 and 1 are not null. That means that we can add them up. So I'm going to add them up like this, 4. Okay, and now what I need to do is merge the left subtree with the left subtree, but it's null for in our case, and the right subtree with the right subtree. So I'm going to call this 1.1 with 1.1, 1.2 with 1.2. Okay, so if we want to merge 1.1 with 1.1, because one of those roots is null, we can just return the other one. So we can return 5 here. Okay, and again I'm going to try to merge 1.2 with 1.2, because one of the two roots is null. I can return just the other one, 4. Okay, now I have finished with the right side. I can just remove this. Oh nope, not this. Sorry about that. Move this, move this, move this, and move this. Now I need the right side. So 2 and 3, 7. So 3 and 2 are both not null. So the roots of our subtree are not null. So we can add them up. So 3 and 2 is 5. Okay, and now I need to merge the new subtrees that are these ones. I'm going to call 2.1 with 2.1 and 2.2 with 2.2. So this one with this one. So 2.1, 2.1 both are null, so nothing is going to happen here. And 2.2 with 2.2, one of the roots is null, so that means that we should return the other one. Okay, so let us check again. 1 plus 2 is 3, 3 plus 1 is 4, 2 plus 3 is 5. We have 5 here and 4 here and 7, so that's correct. So now let us translate this algorithm into code. So the first thing we need to check if the root 1 is null. If the root 1 is null, we just return the other root. And again, we need to check if the root 2 is null. If that's the case, we'll just return the other root. Okay? Then, if both the roots are not null, that means that we need to add them. And to add them, I'm going to create a new tree node and add up the values of root 1 and root 2. And after that, I need to put in my root left a recursive call of merge trees, but this time with the root 1 left and root 2 left. So now I need to merge the left side of the both our two initial trees, and I need to do the same for the right side. And at the end, I just return my root. Okay, so everything seems correct. I'm going to run the code. It's correct. I'm going to submit the code, and it's correct. Now let us talk about space and time complexity. So for the time complexity, as you can see here, we have two recursive calls. But these two recursive calls will just go through half of our initial data. Okay, so the time complexity equation would be T of n to Tn divided by 2. Oops, didn't mean to do that. Plus O of 1. And as I said multiple times, the solution of this is T of O of n. So it's linear, okay? Great. So this is the time complexity, and the space complexity would be also O of n. So time and space. Because it's a recursive function, we will have a call stack, and call stack can go through almost n times. That is the actual the height of the tree. Okay, so this is it. Thank you for watching. See you in the next video. Bye.